Hey everyone, it's David Bombal coming to you from Oxford in the United Kingdom. I'm on a call again with Hank Preston, who's based in the US. Hank and I have been discussing, based on your questions, topics to discuss, and we've got a long list of topics to talk about. But in this video, Hank is going to hopefully talk about Yang models. You know, what is that? And NetConf. So Hank, welcome to the call again. It's great to have you.
Absolutely, David. Thanks for having me back.
I'm really looking forward to this because a lot of people seem to struggle with NetConf. And Yang models and Yang seems really complicated. So I'm hoping that you can kind of shed some light on it and, you know, explain it to a network engineer type of person.
Yeah, no, I'm looking forward to it. It's one of my favorite topics to talk about, partially because it was the first topic in network programmability that I jumped into when I joined the DevNet team. It's a bit of an interesting story. Like my first week, I was in a training, and one of the topics was NetConf and Yang and RESTCONF. And so I went through the training that was going through and going into it, and I just didn't feel like I understood it as well as I wanted to. I had a ton of questions. I was engaging in dialogue and chatter with the other engineers and folks that were in the room, and it was one of those that I was like, I felt like we could do a better job at explaining kind of how these topics go together. And like any good comment like that, it was assigned to me as my first job, kind of as I came into DevNet, is like, well, see what you can do with it. And so that was the first one I dove into. And so I've kind of really fallen in love a little bit with kind of explaining and talking about kind of all of this model-driven programmability, which is kind of the generic term for these types of interfaces where there's a data model, and we'll talk exactly about what a data model is. And then you use that model to actually kind of interface with the device or the devices that are there rather than kind of just particular API calls. Like everything is focused around this data model, and for the network, Yang is the term that kind of dives into when we hear the word Yang, that's what we're referring to, are all these data models, these representations of what the devices have and what you can do with them on that side. And so I think it'll be a good discussion.
Yeah, really looking forward to it. And I believe you've also got a demo where you can show us practically how this works. I'm assuming it's another DevNet demo, yeah?
It is, yeah. We'll go through. So we can jump over to start out here. So what I've opened up here is just a terminal window, and we'll spend probably a lot of today in terminal windows and in interactive Python pieces as we dive through.
Right.
And so sometimes we always talk about NetConf and Yang kind of in that format. NetConf, Yang, NetConf, Yang. But one of the first things I realized as I was diving into it is it makes more sense to start with the Yang side of it. Because Yang is where we're talking about the types of data, what it is we're looking through. And I've used the word data model a couple of times. And so if I do like a quick ls-l, what we see here are a handful of .yang files. And so what these .yang files are, I'll actually highlight this one because it's the one we'll be talking a bunch about, is Yang at its heart is an IETF standard, and it's a standard for a modeling language to write data models. And so before we look at the Yang, let's make sure we're on the same page about what a data model is. I describe data models as this kind of intuitive way that we all understand some object that's out there. And so I leave networking behind usually when I introduce this. And the idea is, let's think about the concept of a person or a people or a group of people. And by and large, everybody out there has just kind of baked into their psyche what a person is, right? A person has a height. Here in the States, we do feet and inches. Everywhere else in the world pretty much does meters and centimeters as it goes through. But people have height. People have hair color and eye color, or lack of hair if they don't have it. People have ages. There's genders, there's skin tone, there's all of these things. And so because everybody in the world kind of understands the concept of a person basically the same way, we can give descriptions to folks and say, you know what, go find Hank, right? Hank's about almost 6 feet tall. He wishes he was 6 feet, but he's not quite 6 feet tall. He's got brown hair, he's got brown eyes, a little bit of facial hair going on, and he's Caucasian. And so with a description like that, pretty much everybody in the world can understand in general what Hank is, right? And because we all have this built-in data model, we can describe and talk about people. Does that make sense?
Yeah, so it's like attributes or descriptions of something.
Right. Exactly. And so when we talk about Yang, what Yang is, Yang was this standard that was written in the IETF, and it is a language to build and describe data models for kind of computer programming. And now you can use Yang to describe a data model for anything. And in fact, if you go look at the RFC, which I don't necessarily recommend to everybody, but sometimes it's good to go back to the RFCs, you'll find that the data models that they use in the examples have nothing to do with networking because they didn't want to tie the Yang language to networking. However, the vast majority of practical uses of Yang are for data models related to the network. And so what a Yang model is it's a very descriptive way to describe some element of the network. And so I highlighted here the IETF interfaces.yang file. And so that is a text file. We'll open it in just a second. That is the IETF's description of a standard way to talk about what an interface looks like. And so you'll also find Yang models for what is the way to describe an access control list, an ACL, or a routing protocol, or anything else you can think about you might want to describe and talk about in the network. And so the importance of having these data models is if the vendors of the equipment say, okay, we're going to use this data model. This is how we're going to describe an interface. And then network engineers like you and I can say, okay, we know what the interface is. We're all kind of on that same page about what an interface is. And then software vendors, people building network management systems, can use those same Yang models and say, okay, that's what a network interface is. And so there's this very strong consistency. We all agree upon what an interface looks like. And that seems so obvious, right? We all know what an interface is. But if you think about it, the way an interface is configured and described, even within Cisco's portfolio across iOS, iOS XE, NXOS, XR, and these other pieces, traditionally, the data model that we had was a very kind of loose data model focused on the Cisco configuration and CLI commands that went in. And that's okay if the person using it is kind of you or I, and we're just kind of reading and interfacing with the CLI. But when you're writing interactive programs or Python scripts or a network management system, it's really important to have a very strong and consistent data model for these things that go across. And so that's really what Yang is it's this way to say, okay, everybody is going to agree very wholeheartedly on this is what the data models look like. And I'm going to start out, before we look at the actual Yang language, we're going to show it this data model in the way that I typically work with it as an operator, which is in kind of a formatted function. And I'm going to use a Python program called pyang or pyang, depends on how you want to say it, to go ahead and represent this. So I'm going to use pyang-f, that's for format, and I'm going to format it in just a text tree. And we're going to look at the IETF interfaces.yang file. And so what pyang does is it reads through the Yang language file and then represents it in a format that we asked for. And in this case, I asked for it to represent it in this text-based tree format. And so what we see here is this is the Yang model for the IETF interfaces. And we can kind of start to dive into what the Yang models include. At the top level, we see these things here. We see this plus indication and then RW interfaces. And then at that same level in the tree down here is this plus and then RO interfaces state. And what these indicate, these are top level container objects inside of the data model. Because if we think about an interface, most network devices have more than one of them. And so the Yang has this concept of a container object. And so we've got an interfaces container. That container will contain one or more interface objects. And so we can see here, we've got the interface object that goes through. Each interface needs to be able to be uniquely identified. And so inside of a container, every item, there has to be some attribute that is considered the key attribute, kind of that unique attribute. And that's what this name inside of square brackets indicates. This says that every interface will be uniquely identified by its name. That's what where it goes through on that. And then underneath the interface, we see each interface will also have a series of attributes or properties. And so an interface has a name, a description, a type, an enabled status, and then kind of trap enable pieces. And from the IETF's perspective, this is what an interface configuration would look like. Now, I use the word configuration because this RW indication at the beginning of this, everything inside of this container, indicates that these are read-write attributes. And if we think about it, a read-write attribute, that's something we can configure. Down below, we see all of these RO attributes. RO are read-only attributes, and those would be operational status. And so that's the other piece that Yang models give us, is Yang models give us the ability to not just deal with configuration of the network device, but also kind of the current state, the statistics, information about it. And so in this RO area called interface state, right? So it's the state of a particular interface. We see it also has interfaces, and they're keyed off of by name, just like the interface configuration. And then we see the RO attributes, the operational attributes. And some of them seem similar, right? Name, so we'll have a read-only status for a name. We'll have type, admin status, operational status. And then we can see all the counters and statistics information that are in there. And so the data model gives us this ability to say, okay, we can configure an interface. We can set its description. We can set its type. We can set its name, things like that. And then we can also read the status of this interface using the interface's state element of this model that goes through. I'll pause for a second, see if you've got any questions on that bit so far.
Yeah, so I mean, just as an analogy, I think we mentioned this before. This is like a MIB in SNMP, or was that too far a jump?
No, that's a perfect one. And that's actually the best example of kind of where Yang came from and where NetConf came from. Is it's the evolution of our standard protocols for managing the network. And what we typically have been SNMP as kind of the way we connect and talk to a device, and then MIBs have been kind of that data model for the SNMP world. And so the Yang is definitely, the best analogy you can think about is to a MIB, and it's a description that goes through on that side. I joke sometimes that NetConf and Yang would have been called like SNMP v4, if we didn't think that would have just ticked people off and kind of given everybody the wrong taste of it on that side. But in general, that's really what we're looking at, is this next generation update of kind of the SNMP style of interfacing with a device.
But what I notice here is it's a lot easier to read because MIBs are horrendous.
Exactly, yeah. For me, that's one of the things I've used SNMP for years. There were certain MIBs I knew how to go into, but to be honest, right, I didn't know how to find the specific MIB for a particular attribute. I kind of relied on network management tools to kind of do a MIB walk, figure out what was there, go figure something out. What I like about dealing with the Yang data models is they are fairly consumable, right? I can read this. I know what an interface is. I don't have to know the 1.2.0. Right? It's much easier to say it's IETF interfaces and then interfaces state. That's how I get the statistics.
Yeah, and it's also read-write, read-only, similar to kind of like SNMP kind of setup, yeah?
Yep, absolutely. So while we're looking at this, one of the other things I want to talk about is some of the terminology that goes into the Yang models. And so I already used the word container, right? So we've got the containers, and we've got two of them in this model. We've got an interfaces container, and then we've got the interfaces state container. Now, all of these attributes that are here, the name, the description, the type, inside of Yang, those are referred to as leafs. And so every attribute, every property that's inside of the data model that will hold some piece of data, Yang refers to those as leafs. And this is one of the other things that super confused me when I first started working with NetConf Yang, is I would hear the term leaf, and by that point, I had already kind of figured out in the context of networking what a leaf was. And a leaf represented kind of an edge switch and a spine leaf topology. And so, I mean, it took me forever to realize that when talking about Yang and hearing the word leaf, it had nothing to do with a leaf node and a topology. It was just this attribute. And so that's the other big piece to kind of recognize as we dive in, is that you'll hear these terms leafs, or when we talk about accessing or going into a leaf with a Yang model, all we're talking about is just one piece of data, one attribute, one element of information that we're interested in. So we would say the name leaf or the in octets leaf. These are pieces of information. And that's another big one. I think having some of these just terminology and how to work with it will help people get miles ahead as they kind of dive into some of these new protocols.
No, agreed. I mean, when you mentioned containers, I was thinking Docker, which has got nothing to do with this.
Yeah.
It's got nothing to do with it.
And then leaves, spine and leaf.
Leaf.
So it's got nothing to do with the spine and leaf architecture.
All right. So what I like about this view and using the Pyang tool is this is what I like to call kind of the network operator's view, or the consumer of the Yang model. And I would say that this is where most network engineers probably should stay, is using something like Pyang to investigate it this way. But it's also interesting to kind of look at what the native Yang language looks like. So let's go ahead and look at what the actual text file for this looks like. So remember, I was able to show the interesting bits of this model basically on my screen here all by itself. I can see everything I'm interested in. I can see what's there. But if I go ahead and instead, I'll use the tool less to print out the raw text. And so we'll say IETF interfaces.yang, and there. So now what we've dove into is I'm just looking at the raw text. And so now what we're seeing is the Yang language. And this is what the IETF standard really is. The IETF standard is not about what an interface looks like or what a routing protocol is. The Yang standard is just how we write these text files. And if you are a software vendor, if you are a hardware vendor, and it's your responsibility to kind of build a Yang model to share with operators on how to go through, these are the folks that are actually working in the Yang language to write these. And it's not that these aren't readable, right? It's pretty easy to go through and say, okay, this is the IETF interfaces module, and a module in the Yang framework is one of these models, right? Model and module are loosely interchangeable as terms as they go through. And so this is the module, or the model from the IETF about the interfaces. We see this reference to namespace. What a namespace is, and we'll see more about namespaces when we dive into NetConf as we're working with the Yang models, but this is how inside of NetConf we can distinguish between different Yang models that a device might support. Because any one network switch or router will likely support dozens, if not hundreds, of different Yang models for different aspects of the configuration from different sources. And so there needs to be a unique way to identify a particular Yang model, and that's this namespace concept. And so we can see this is the way that this will be namespaced, and we'll see that in other areas. We'll see the organization. So there's all this metadata, contact information, kind of who was responsible for writing this model. And if I scroll down, we'll see the description. We'll see revision information. So this version of this model happened to be the 2014 from May revision, and there's been other revisions that have gone through. If I scroll down a little bit farther, we'll see type definitions. I didn't mention it before, but we saw them in there. If you were looking at the Pyang output, every leaf had a type. It was either a string or a date time, might have been an interface type. And the Yang language, the standard states that every leaf needs to have a very specific type associated with it. And so as a developer or user, you know what to expect. So when you request something about an IP address, it's going to come back and it's going to look like an IP address. And there's a very specific way that those IP addresses will be represented. Same thing with physical addresses on that side. And so we'll see types that are in here. We'll see identities and features. These are all elements of kind of how these models go through. And then finally, way down here, and I don't know what line I'm on, but I'm quite a bit down, we finally get into this reference to container interfaces. So everything above this, from an operator's perspective, we don't have to pay that much attention to those details. We get into the container interfaces, which is what we are interested in. And now we see all of this extra detail. We see the description that goes in. We'll see, okay, there's inside the container, there'll be a list of interfaces. We see the key of name. We scroll down some more and we'll see all of the leafs that are there. My personal opinion is that this type of a layout from a general network operator's view is probably way more information and way more verbose than a typical network engineer trying to consume a Yang model needs.
Agreed.
That's why I always go back to that Pyang, because it makes it so much easier. It hones in on the specific information that I'm after, but you can always go back and you can look at the details that are inside of the Yang file. And so we can see leaf name, we see all these pieces, we can see the very specific descriptions and details about every leaf. There's good info in here, but in general, a network operator probably doesn't have to deal with the raw Yang files that often. Does that make sense?
Yeah, so I mean, just for comfort, we don't, as network engineers, we don't have to create a Yang model. Cisco's doing that. And you doing that using the Yang language. So a developer at Cisco or someone is using the Yang language if I'm saying that right, to create a Yang model for a Cisco some router. Is that right?
Yeah, actually, yeah, that's perfect. And that's actually a good place, good segue into the next topic we should go through is who creates the Yang models and where do we get them? You mentioned Cisco creates them, and so indeed we do. And every software, hardware, network vendor out there is likely creating Yang models specific for their devices. But if you'll note, the one that we've been looking at so far is called IETF interfaces. And so that's the other thing that's really nice about this kind of move to NetConf and Yang and these standard models is that Cisco, in addition to writing our own models, we also support the ones that are coming from the standards community. And so the IETF has written and provided Yang models for representing network concepts. And so this was the interfaces one. There's also an organization called OpenConfig. And OpenConfig isn't an official standards body like the IETF is. What OpenConfig is kind of a consortium of network operators, service providers, software vendors, hardware vendors, who are coming together and saying, okay, let's figure out effective models, effective descriptions for network pieces that we can use commonly across vendors that are there. And so some of the members of OpenConfig are companies like AT&T and Verizon, BT Telecom, Cisco's in there, Juniper's in there. And so everybody's coming together and saying, okay, we need to describe what a VRF looks like, what a virtual routing and forwarding fabric looks like. And Cisco has their way of doing it. Juniper has their way of doing it. Each operator, each service provider may have their own way they think about what a VRF looks like. And so what they do inside the OpenConfig is they say, okay, let's come together and let's agree upon what a VRF looks like or what BGP routing looks like. And so they create a Yang model and says, okay, this is a Yang model out of the OpenConfig, and it's our description of how we want to deal and interface with this type of a network thing, like a VRF or something like BGP. And then it gets put out there, and then vendors like Cisco can say, okay, we're going to support the OpenConfig models in addition to the IETF models that go through because in general, the OpenConfig models are far more complete than what you might get out of the IETF. I like the IETF models for things like teaching concepts and kind of understanding the basics of how something like NetConf, Yang, and RESTCONF work. But fundamentally, most folks are not going to find all of the flexibility that they want or work through the IETF models. More often, they're going to use a model from OpenConfig, which are very common, or the other source, and we started here, is they're often called kind of native models. And a native model would be a model from the software or hardware vendor themselves. And so Cisco has native models for iOS XE and NXOS. And that what you'll find in the native models are the things that are unique to those platforms from those vendors or inside of that software. And so OpenConfig is going to support, I always like to say that's the common aspects of something like BGP. But those specific innovations, those things that make Cisco's implementation of BGP kind of their kind of value add or specific way that they look at it and the specific way that Juniper does it and everybody else, odds are good we're not going to see those things make it into a standard model from the IETF or OpenConfig, but we still want to make sure that customers can consume those capabilities through Yang models like this, and that's where the native models come through on that side. Does that make sense?
Yeah, it does. So, I mean, you mentioned iOS XE as an example. So they would be, what you would, just to summarize, native models are Cisco models that we can interrogate or use via NetConf to change something or just pull back stats. And then you've got OpenConfig, which is like a consortium of vendors and people. And then you've got the IETF. So one of the first things as a network engineer that I would need to find out about if I want to use NetConf is which models some device supports. So to be the cynical network engineer that I am, a Cisco iOS router from 5 years ago isn't going to help me, kind of thing. Is that right?
Yep. So on that one, so you definitely, one of the first steps you want to do when working with a device through NetConf and with these models is to understand what they support, and that's loosely we'll call those capabilities. And so what are the capabilities? What are the data models that are supported? And And so we'll talk in a minute about how you can figure that out. And so the question about something from 5 years ago, does it support it? It's a very valid question, and we have to go through on this. So if we think about inside of iOS space, so ISR routers, Catalyst switches, ASR routers, that type of portfolio, the NetConf Yang features came inside of what we called the kind of the Denali release code. And in general, this means 16.2, 16.3 and higher. And so if you do have a bunch of 3750 V2s or 3650s, or the older switches out there that are running code and they can't be upgraded to the newer iOS XE software versions, then yes, unfortunately, you're not going to be able to take advantage of these pieces there because the interfaces weren't there.
Yeah.
That doesn't mean 5-year-old stuff isn't supported. If you go back and you look at some of the Nexus portfolio, one of the things that's interesting is some of the data center equipment and the larger service provider equipment has been supporting some of these protocols for many, many years. From the get-go, the initial shipping of some of the NXOS switches, they had NetConf support. They actually had NetConf support before the Yang standard and the Yang models were there. And so we've seen a lot of these protocols out there for years, but you definitely do need to make sure that what's supported where. Let me bring up real quick how you can figure out what some of those details are. Where is it? So I'm going to go to a page up on DevNet, developer.cisco.com/netconf. NetConf, there it goes. And I'm going to make the page a bit bigger so we can read it. And so this is a page we maintain up on DevNet around model-driven programmability. And so you'll find details on this page for all of the things that fall in. So this is in addition to Yang and NetConf, you'll also see references to RESTCONF, which is a REST API version and way to consume the Yang models. And then GRPC, which is Google RPC. It's another transport protocol in addition to NetConf and RESTCONF that you can use with Yang models. But on this page, down near the bottom, and I'll scroll down, whoops, here it is. We've put together a chart that shows kind of which platforms, what software versions support the different protocols and things that are there.
Oh, this is great.
And so from a
great.
Yeah. And the reason that we don't see Yang called out here is because the Yang models and the capabilities list, those are easy to find in another location we'll jump to in just a second. But what's more important to understand is when are the transport protocols, how we actually communicate with the device. And so if Yang is like MIB, NetConf, RESTCONF, and GRPC are like SNMP versions that are there. And so this chart says, okay, these iOS XE has supported NetConf, and here's the RFC version of NetConf. On the Catalyst 4500 since iOS XE 3.91, on iOS XE across these platforms since 16.3, on the Catalyst 9K 16.6, which is actually the first version of software that the Catalyst 9K shipped with on that side, and so you can see from there. If you leverage the iOS XR platform, it's actually had it for quite a long time here, so you can see when it's been supported there. And then the same thing on NXOS. And so you'll notice down here we've got support across the portfolio for those. And then on the Yang model support, and so we'll look in a minute when we actually get into kind of the NetConf area, how you can use NetConf itself to ask a device what models are supported. But one of the things that I really like about working with NetConf and Yang is how easy it is to find some of these details. And so let me make this bigger so we can see it easier. So up on GitHub, there's an organization called Yang Models, and then in there's a repo Yang. And this is a location where you can find the IETF as well as vendor-specific models from Cisco, as well as a lot of different vendors that are there. And so, for example, if I come down here, and we'll start with the standard. So I can go into the standard folder, and then I can see that the IETF, the IEEE, MEF, ODP, these are where you can find these standard organizations, what their models look like and what their definitions are. And so if I go into the IETF, and then I can see that they've got draft and RFC versions of these. And then if I look, we'll actually find, there it is right there, IETF interfaces.yang. So this is that model we were looking at. So we can find the Yang file right up on GitHub, and we can find these across the standards. If I go back to the top of the repo, and I look in the vendor folder, we'll see that Cisco, Huawei, Juniper, and Ciena all post their models and their model support up in the same place that goes through. So we'll dive into the Cisco folder. In here, I can see that I've got NXOS, XE, XR. And so we'll stick with XE for a moment. So I'll look at XE. I'll see in here that we've got folders based on software versions. And so this is the version 16.3.1, 16.3.2, .4.1. And so we'll be working, I think the demo we'll be going on today is on 16.7, I think is what we're looking at. But when I go into this folder, now I can see all of the models that are supported and the references that are there from the native perspective. And so here what we're seeing, these references are the Cisco iOS XE AAA Yang. That is the Cisco native model to describe AAA authentication that's there.
That's great.
I can see ACL, ARP, and all of these. And so it's it really is quite simple to find out what are the models that are supported, and then get access to them so that you can use a tool like PYang to actually inquire and navigate through them as they go through. You'll notice on Cisco iOS here, we'll see quite a few models that are there, because the way that the native model structure is done for Cisco iOS is we've modularized the Yang models. And so the one that you actually start out with is a model called native. And let me find it in the list here. There it is. And so the top level model is this one that's called native. And that's where you start out with. And then native then kind of imports all of these other ones. And it makes it easier for the software developers, the Yang developers, to say, you know what, I only want to work on the MPLS portion. And so MPLS gets pulled out into its own Yang model. They focus in on that. They can make changes there without having to change the one gigantic model that's there. And there are different approaches to dealing with the models. And in the iOS XE team decided to use this kind of modular fashion so that they can say, okay, we're going to have MPLS defined here. We're going to have NAT defined here. We're going to have NTP defined here, rather than having one model that defines them all inside it. You'll actually see the opposite approach was taken by the NXOS team. There's a single NXOS native model that kind of has everything in it, rather than these other ones that go through. Having worked with both, I can see pluses and minuses on both sides of those. It just kind of comes down to what the particular team building the models decides on that side for that. Does that make sense?
So, Hank, one question I had is on that list of devices, I didn't see Cisco CSR virtual routers. If I wanted to use GNS3 or something else to practice this, is that supported?
It is. I'll flip back. It should have been listed.
I probably missed it.
Yep, right there. Yeah,
CSR there we
1000.
Go. Yeah, that's what I was looking for. So that's great.
I know it is, because all of our learning labs actually use a CSR 1000V in a sandbox. And when I jump to the live demo, I'll be using our public CSR to make all the queries against. So,
but that's great. So I mean, that means if I wanted to practice this, I could use the DevNet labs, or I could have a CSR and just play with that.
Yep. And that's one of the things that I really like about working with these things today is it's so much easier than the old days of having to hit eBay and trying to find a switch.
Yeah.
So many things are available through different virtual platforms. And that it's so easy to go through. And from a production network perspective, the question about old gear is super valid. But from a learning about it perspective, it is so easy to say, okay, you know what, you want to learn about this? Go grab the CSR version, or go grab the Nexus 9000V version, or nearly every vendor is providing virtual versions of their pieces. And so the CSR 1000V is a great way to explore and learn about. And in fact, it's what we use in all of our learning labs that I wrote on these topics.
That's great.
Mm-hmm. Yep. All right, so that hits some of those pieces on that side. I'm going to jump back over here to the terminal window. And so that's the Yang foundation that's there. The next thing I want to talk about is let's talk about where does NetConf fit into this. And so the Yang standard, the Yang models are just a description of these different types of things we want to talk about. It's a data model that says, okay, an interface is going to look like this, routing protocol looks like this. NetConf is what I call the transport protocol side of this. NetConf has no idea what an interface is, but NetConf knows how to connect to a device securely. It knows how to authenticate. It knows how to package up a request and send a request to retrieve information or send configuration details in there. And so NetConf is the protocol that we actually use to reach out and communicate with some device that's out there. On that side. Now, NetConf is one protocol. RESTCONF is another protocol. And so NetConf, we'll talk and we'll see in a minute, NetConf runs over the top of SSH. It's kind of built in that typical kind of network framework, moving over the SSH protocol, leverages XML under the hood. RESTCONF kind of builds in the vein of REST API style. So RESTCONF runs over HTTP. It leverages REST API standards like headers and authentication pieces that are in there. But both NetConf and RESTConf point and leverage the exact same Yang models that are there. And so if a device supports, for example, this IETF interfaces model, I can communicate with the device over either NetConf or RESTConf and get access to all of the same details that are there. Does that part make sense?
Yeah, that's great. So, I mean, I wanted to ask you and you've explained it, so that's great. Just to summarize, NetConf is better than SNMP because it's more secure. Well, one of many benefits because it's leveraging SSH. RESTConf basically uses REST API. So kind of, is it correct to say that's kind of like HTTP, HTTPS type of REST APIs, whereas NetConf uses SSH?
Yes. Yep. Yeah. So and we'll see this, and I'm actually going to grab my notes and we'll show how we can actually use a typical SSH interface to send NetConf commands, and then we'll look at the real way. We'll do it after that. And then with RESTConf, we'll go over HTTPS.
Okay.
It's a REST-based protocol, but with the standard for RESTConf, the decision was made when they finally standardized it to not support clear text HTTP. And so some of the early drafts of RESTConf actually let you go over port 80 without having to do any kind of security and encryption and all those other pieces. When they finally standardized it, they said, you know what? Why even bother supporting the clear text? It doesn't make any sense in this day and age. And so standard RESTConf requires HTTPS for security on that side. And that's the one piece to go through and kind of keep in mind as you see that. Does that make sense?
Yeah. Sorry, I don't want to keep harping it too long, but quickly, why would I use one over the other?
You mean RESTConf versus NetConf?
Yes.
So if the devices support both, it comes down to, I would say, two factors. The first one is personal preference. If you prefer to use RESTConf as a REST API, then there's a great reason to use it. A lot of people, and I'm just getting myself prepped here for a second. A lot of people use RESTConf because they prefer the REST API interaction. And so that's a great one. And personally, I'm in that same bucket. If given the choice, I'll use a REST API over using a non-REST API because they're simpler to use. The interfaces are super easy. They kind of match a lot of the patterns we're going in other places. The other reason you might go to NetConf is NetConf was the first transport protocol that was standardized by the standards bodies. It is more mature. And so you'll actually find lots of devices, actually most network devices today don't support standard RESTConf. And I usually caution folks about kind of spending a lot of time on draft versions of RESTConf because you may find the things that were done in draft got changed later on, and it can be confusing because you thought you learned it one way and now it's changed to something else. And so I caution on that side. So device support is one reason why you may not be able to use RESTConf. And the other one is RESTConf and NetConf from a basic configuration and operational details perspective are pretty at parity. If I want to configure an interface or get details on a protocol, I can do that from both NetConf and RESTConf. But when we start to look at some of the other types of use cases, things like streaming telemetry, when you want to subscribe to something or feed details in, some of those more advanced use cases around model-driven programmability aren't supported in RESTConf. They're only supported in NetConf. So it's a long and complicated answer. If I had to shorten it down to two pieces, the first one is most people will start with RESTConf if it's supported. If it's not supported, go to NetConf. You have to learn NetConf because that is the one that is supported on most of the devices today. And then the second piece is, if you're trying to do something more advanced, you may find yourself needing to use NetConf on that side. I actually don't know if that was any shorter of an explanation than the first one I did, but that's kind of the...
No, that's great. I mean, rather more details better, so that's great. So moving forward, which one do you think's going to win, if you like?
You know, so that's an opinion question. When we look out, when we have robust and kind of support all over the place for RESTCONF, I think we'll find most network engineers, application developers are going to RESTCONF because the REST API syntax that's there. However, I think network management software vendors, folks like SolarWinds or even Cisco, our platforms that do network management, will probably prefer NetConf because of some of the efficiencies that it offers, because of some of the things that it does under the hood. And so I honestly don't think one will win out over the other. They'll both be supported, but maybe used by different people for different types of purposes.
That's great. And I don't want to diverge too much, but you mentioned a Google protocol as well. Like you had 3 in that list. Is that like a new emerging, supposedly good thing, replacement, or just another option?
So today it's definitely emerging. I would say that today it's another option. GRPC for Google RPC, it came out from the guys at Google because they wanted a standard and common way to interface with basically everything in their data center. So whether it was a switch, a router, a server, a microservice, they wanted everything to be able to kind of run over the same type of transport protocol. And so they created this gRPC protocol to do for that. It's a great point. I totally agree with Google on this side. Being able to kind of consume and work with everything using the same protocols makes a ton of sense. And so I think we'll see it uptick go through. However, what we're actually finding is most of the use cases for gRPC are not for the typical configuration or operational queries. If you want to configure an interface, you're not using gRPC for that. If you just want to go out and reach, hey, what are the current statistics or stats about this particular routing protocol? gRPC is probably not for use for that. Where gRPC fits in is what I usually call these days model-driven telemetry. And the reason I hesitated for a second there is some of these things haven't really settled in on a specific name that is kind of going to be what the industry agrees on.
Yeah.
It's sometimes also called streaming telemetry. And it's this concept of an idea of rather than going out and polling your device for telemetry or health or statistics every 5 seconds or 30 seconds, or rather than setting a device up to send traps based on some sort of a piece, streaming telemetry or model-driven telemetry say, okay, we're just going to set up kind of this connection between the collection system and then the devices that are there, and then any piece of information, as soon as that piece of information happens at an edge, we're going to stream that kind of as near to real time as possible up to the collection devices. That use case of this streaming or this model-driven telemetry is where gRPC really is used today. And I honestly think where its primary use case is going to be around those types of pieces, not these kind of configuration use cases or like query-based operational use cases that are there. Though again, some of that's just my opinion based on what I'm seeing today and talking with folks. That could change over time, kind of as these different protocols mature more. So,
well, that's great. It's always nice to get your opinion. I've muddied the waters. So at some point, either now or later, will you tell us, if I'm new to this, where to start? So I'm assuming we should start with Yang and NetConf and later on move into these other things. But sorry, I've kind of taken us on a tangent here. Sorry, Hank.
Oh no, they were a great dialogue. I will say we'll definitely. So one of the things we'll probably end is with this discussion, and then we'll make sure that the links are included with the video, are recommended places to get started. And so I mentioned at the very start of the video that the first project I undertook when I joined the DevNet team was to try to make it easier to understand and go through these. And so I've written and then updated a handful of learning labs on Yang, NetConf, and RESTCONF. And those are great places to start. They talk through the fundamentals. You get the chance to interact live with our sandbox equipment. There's code samples that walk through and explain how they all work. I always start there. I've also done some video lessons as part of the video course that we've talked about in previous videos that kind of walk through more of these pieces, I think that's another great spot for folks. This is a good introduction. Go watch those videos. You kind of get to see me work through some slides, some more demo examples on the topics, and then the learning labs that are there. So we'll make sure links to all those resources are included in the video.
Great.